If you look at problem 61, it's a question related to attenuation. It can be interpreted as asking about the rate of attenuation in soft tissue. Looking at the units, you can see that they are related to the attenuation coefficient. Since soft tissue is the standard value, you need to memorize the attenuation coefficient for it. The correct answer would be option C. Remember that approximately 0.5 is the attenuation coefficient observed in soft tissue, which serves as the standard value. Next, let's move on and look at question number 62. Since this question was explained in the previous lecture, let's go straight to the answer. This question asks what needs to be measured higher for the speed to increase. The correct answer would be option C. I previously explained the law of speed, saying that when S meets at the front, the speed increases. So you can check the answer as hardness. Let's look at question number 63 right below. If you look at the question, it says that the acoustic pressure has increased. An increase in pressure means that a lot of energy is concentrated in that area. You can see that as a result, it is also related to an increase in strength. Therefore, if you see this type of sentence, you should understand through the question that it is related to an increase in strength. Next, let's move on and look at question number 64. If we start by interpreting the sentence in the context of an abdominal ultrasound examination, this expression means to face or to encounter. This question is asking which view is expected to encounter refraction. There are various organs in the abdomen, and during this examination, reflection and refraction can be encountered, which refers to the shadowing that falls off to the side of a rounded structure. This question asks you to choose the option where this phenomenon is most likely to be encountered. The correct answer can be seen as option B. Yes, when scanning the gallbladder, since the gallbladder itself has this kind of rounded structure, you can observe shadowing on its side. Let's take a look at the related video. As you can see in the image, this is the appearance of the gallbladder observed on abdominal ultrasound. If there is a curved structure at the end, a difference in speed occurs, and lateral shadowing may appear as a characteristic. Even if it's not the gallbladder, if a rounded structure is mentioned in abdominal ultrasound or due to disease, keep in mind that refraction can occur at the end of such structures. Let's go back to the question and carefully look at what the question is asking. In particular, having background knowledge of abdominal ultrasound, or the most basic vascular ultrasound, such as carotid ultrasound, will be helpful in solving the questions. Next, let's move on and look at question number 65. This is a question related to attenuation. In the case of this question, you can see it as a pattern where you can organize the content through problem solving. You are supposed to find the option that is not related to attenuation. From option A to option D, reflection, scattering, conversion to heat, and absorption, these can all be considered as the same concept. These are the keywords that can be considered related to the attenuation of the ultrasound beam. Compression, which is listed in option E, is not related. So, through problem solving, you should look at the keywords related to attenuation. Now, let's look at question number 66 right below. Since this question is asking about terminology, in such cases, you can just find the correct answer right away and review the content. It's a reflection phenomenon that occurs on a large surface with a big size. Yes, smooth and interface. We've covered these in a previous lecture. The correct answer is C, which is specular reflection. Next, let's move on and look at question number 67. Looking at the question, it asks about inspecting the weld area using ultrasound, and if the inspection is conducted at a 45-degree angle, what is this called? If the angle itself is not 90 degrees but 45 degrees, you can expect that the ultrasound enters at a slant. In such cases, you can consider it as an expression related to oblique incidence. Simply put, because it doesn't go in vertically, it enters at an angle. So, just remember that it is related to oblique incidence or oblique insertion. Let's look at question number 68 below. This is related to the question we just solved. Similarly, when performing the AOTF test, the beam is incident on the image at a 45-degree angle. If the angle is set at 45 degrees like this, then the reflected angle can also be 45 degrees. If the inspection is conducted this way, the reflected value may appear in a different direction compared to when it is done vertically. So, as a result, we can choose option D as the correct answer. Because the reflected angles move away from the transducer, this can lead to a decrease in image reproduction. You can consider this option as the correct answer. So, you can see this as a question related to the basic concept of incidence and how angles affect the image. Since this type of question is an important pattern, it would be good to organize the content through problem solving. Next, let's move on and look at question 69. If you look at the question, an ultrasound image is provided. Shadowing is observed in the kidney area. This question is asking about what kind of interaction between sound and tissue results in such findings. To summarize, there is a stone in the renal area, and shadowing is seen behind the stone. This question is essentially asking what physical mechanism causes this shadowing to occur. Compared to soft tissue, the area with the stone can be said to have a much greater acoustic impedance difference. As a result of this difference in acoustic impedance, shadowing can be observed. Now, when we think of acoustic impedance difference, a certain word comes to mind. That word is reflection. The mechanism by which shadowing occurs in this way is related to reflection in ultrasound. Because the question mentions a stone, you might mistakenly think it is asking about clinical content. But ultimately, you should see this as a question asking about basic physical concepts through this image. Now, let's move on and look at question number 70. Since this question contains an important concept, I want to emphasize it. To highlight the key point, this question is asking about the relationship between Rayleigh scattering and frequency. The correct answer can be considered as this one. Scattering is proportional to frequency, and when the frequency increases, it has the characteristic of increasing to the fourth power. For example, if the frequency doubles, the scattering increases by the fourth power of that, so you can think of it as increasing to the power of 4. One thing to be careful about is that since it's to the fourth power, you need to calculate it as 16, but sometimes people mistakenly multiply by 4 instead. If you do it that way, the value will be different, so just remember the concept of raising it to the fourth power. To summarize once again, the concept of Rayleigh scattering comes up. If you're asked about its relationship with frequency, just remember that it increases to the fourth power as shown above.